In this video, I'm going to go through section 2.1, which was calculating and interpreting z-scores. So they gave us a formula for z-scores that is the value minus the mean divided by the standard deviation. So remember that this formula gives us a value that describes how far away from the mean each data value lies. So I'm going to go through an example just to because one of the, or two of the quiz questions do have you go through the whole process of finding standard deviation. And so remember that this will be on the test. You will have to do this later. So you might not get a quiz question that has this, but there are some that do require you to calculate the standard deviation and mean on your own in order to find the z-score. So if we're given the following test scores, they want us to find the z-score of a student that scored 43 points and the z-score of a student who scored 55 points. So what I've done in my table to find standard deviation, so remember that the first column is listing the data values. You'll notice that I listed them in order. The reason that I like to do that is because then when I have repeated values, I can just copy down my answer. I don't have to kind of look and search for it. It also gives me an idea as to when things should turn from positive to negative when I'm doing the difference, even though remember that when I square the difference, it's always going to be positive. So when I'm finding the standard deviation, I'm using this formula. So remember that this expression, sigma of x minus x bar squared, means the sum of all of these values. So I'm going to take all those values and add them together, and that will give me, that piece, right? So I'm going to add that column. So ultimately from this table, that column is all that I'm taking and using in the formula. So what I want to start by doing is find the mean of the data values. So what that means is I'm going to take all of these data values and add them together. So if I add all these up, I get 414. And again, I did this already, so I'm just copying down my answer. So I am going a little fast. If you wanted to pause and kind of check my work, that would be a good idea. To find the mean, we have to divide that sum by n. Remember, n is the number of data values that we have in the data set. So if I count these, I have 9 scores in my data set. So that means that n is 9. Okay, so what I need in order to find standard deviation or z-score is I need the mean. So I know that the mean is going to be that 414 divided by 9. Okay, so that's going to give me the mean of the data set, which I got as 46. So that means that 46 is the average of the values of these scores. The other thing that I need from my formula, right? I have the value, right? The value is what's given here, 43 in this one, 55 in this one. I now have the mean, and so I also need standard deviation. So that's why I need to fill out the table to find standard deviation. So what I'm going to do then is, now that I have the mean, is I have to subtract the mean from each data point, right? So I'm subtracting 46 from each of these. And I'm just going to do that so that we can see that it's the same value I'm subtracting each time there. So when I subtract 46, I'm going to get negative 11, then I'm going to get negative 3. And then notice I have 46 minus 46. So I'm going to get a bunch of zeros here because I have a lot of 46s in my data set. And then once I've gotten past the 0, 48 should now give me a positive number. So 48 minus 46 is 2, 49 minus 46 is 3, 55 minus 46 is 9. The last step here is that I want to take and square these data values, right? So I'm taking these data values and squaring them, sorry, these differences, and squaring them. Right, that's my next step here. So negative 11 squared is 121. Remember, because I'm squaring numbers, these should all be positive. 3 squared is 9, 0 squared is still 0. 2 squared is 4, 3 squared is 9. And then 9 squared is 81. So to find the standard deviation, I have to add up all these values, and this number is going to be the numerator of that part of my formula. So if I add all that up, I get 224. So looking at that, the formula for standard deviation is that I take the square root of that number. So we got 224, the sum of the differences squared. And then we're dividing by n minus 1. Remember that n was 9, so we're subtracting 1 from 9. So that means that we're going to divide the square root of 224 over 8. Okay, so if I calculate that, that's the square root of 28, which is approximately 5.29. Okay. So I found the sample standard deviation. So S is approximately 5.29. Okay, so remember that this process of finding the standard deviation is something that you did in the section 1A, which was the measures of variability. Okay, so you found standard deviation in measures of variability. We just went through that process one more time, again, because there are a couple quiz questions that do this. So I haven't even come close to answering my question, but now I have all the information that I need to answer the question, right? I have the data values, they gave them to me in the question. I found the mean of 46, and I just found the standard deviation of 5.29. So I'm gonna plug each of those into the z-score formulas. Z-score is equal to the data value, which was the 43, minus the mean, which we got was 46, divided by the standard deviation, which is 5.29. So if I calculate that, I've got negative 3 divided by 5.29. That's negative 0.57. So that means that 43 is 0.57 standard deviations below the mean. Again, I know it's below the mean because it's negative. We're going to do the same thing with the data value of 55. So our z equal to the data point, which was 55, minus the mean, which was our 46, divided by that standard deviation of 5.29. And so if we calculate that, we get approximately 1.70. So that means that 55 is 1.7 standard deviations above the mean. So again, some questions you will literally be given the mean and the standard deviation, and you just have to do this part, right? There are just a couple questions on that quiz where you might get them, but it just gives you the data set. You have to go through that long process of finding the mean and standard deviation before you can answer the question. One thing that I wanted to kind of touch on is knowing when a positive z-score versus a negative z-score is better. So when something is timed, so think a race, the winner will have the lowest z-score, which is a negative one. Okay, if something has a score, so like a game, I think think like gymnastics, diving, right? They're looking at scoring them, giving them points out of a 10 or whatever. The winner will have the highest z-score, which is a positive value. Okay, so keep that in mind when you're answering questions about who's better. So if you're comparing someone from a race to someone in a game, you want to compare the absolute value of the z-score. So for example, if Sally swam in a race and her result was a z-score of negative 2.35, and Gina's score in a gymnastics event had a z-score of 1.78. You're comparing the absolute values. The absolute value of negative 2.35 is bigger than the absolute value of 1.78. So that means Sally did better comparatively. Okay, so even though it's negative, hers is supposed to be negative. Negative is better in that situation. Okay, so those are things that I wanted you to pay attention to and make sure that you reviewed for the section 2-1 quiz. So that's all that I have for that one.